Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we'll be talking about matrix notations today. We're going to talk about how do we represent metrics, okay? The reason why we're going to do this is that we have to make sure that we all understand the matrix notation before we go into the addition, subtraction, multiplication, and the rest of it. All right. So before I start, don't forget to like, share, and subscribe. If you've not clicked the notification bell, I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first person to know. Okay, so in matrix notation, each element in a matrix has its own particular address or location. So there's a way that we try to locate or try to define a particular element in a matrix. So usually use notation something like, if you go to the textbook, you will see something like A32. So that means this is talking about something. So it's a way of us to locate that particular element in the metric set. Now, this number here is a notation. It represents the first number there represents the row, and the next number here represents the column. All right? So it represents the column. So what we are saying is that the element in the third row and the second column. So we usually use the first to indicate the row and the second to indicate the column. All right. So, and it helps us so that we can now say, if I go to the matrix, so A32 is going to be the third row. So this is the first row, the second row, then the third row, and the second column. So this is the first column, the second column. So that means the element is going to be somewhere here. Are you seeing it? So that is how we now know how to define each of these metrics. Now, because I know students do take notes, I'm going to write this down, what I just said, so that it will make more sense to you for your revision. So each element each element in a matrix has its own particular address. So that means there's a way we can locate it, or you can call it location. So each of these elements has its own particular address or location, which can be defined by a system of double suffixes. Okay, so double suffixes. So now what happened here is that the first, okay, the first number there is indicating the row. And the second, okay, indicates the column. Now, these together, all right, so the first and second, right? So now this is referred, so you see it in some textbook, that is referred to as the double suffix notations. Okay, so double suffix notation. So um, what I'm trying to explain here is that if you look at each of these metrics, then you will see that you have the first element. For every element, you have the first suffix, and you also have the second what? The second suffix as well. Okay. So let me give you, for example, okay? So thus, you can be noticing, for example, you will notice, for example, if you have a particular matrix, you can be representing as A. So this is the first row, first column. Are you seeing it? The elements in the first row, first column. Or you can also have first row, second column, first row, third column, first row, fourth column. Are you seeing it? Now, this is in the second row, first column. This is in the second row, second column. This is in the second row, third column. And this is in the second row, fourth column. Now, you can also say this is in the third row, first column, third row, second column, third row, fourth column, and sorry, this is the third row. So this is in the third row, third column, and this is in the third row, fourth column, and this is it. And now when you look at this, remember we talked about the order. So this is how many rows we have. This is a 3x4 matrix. But each of these elements is what we can try to explain. So just for your notes, so we can say, for example, let's pick 2, 3, okay? So A23 indicates or refers, okay, the element in the second row and third column. Okay, so you can have it like that. So usually when there is no ambiguity, for instance, a whole matrix, for instance, can be denoted by a single general element enclosed in the bracket, okay? So we can say, for instance, a particular matrix is A, a particular matrix is IJ, a particular matrix is, it depends how you want to do it. But one thing you need to know is that each of these elements has to be clearly stated, okay? So let me write this down. So what I said was that when there is no ambiguity, okay, a whole matrix can be denoted by a single general element. So enclosed in brackets. So, or by a single letter printed in bold type. Okay, so for example, if you look at this, we have this one. So let's say we have this element. So we have A11, A12, A13. Have you seen it? Or you can say this is A21, A22, and A23. Okay. So now this matrix now So we can denote this matrix. So this matrix can be denoted by, we can say it as Aij. So in some textbook, you see Aij, or you can denote this matrix as A, or if you want to use the bold type, you can use capital letter A. Okay? So what we usually do in order to avoid confusion, we usually, for a n by n matrix, or for instance, in this case, it's a 2 by 3 matrix, we can use both capital letters to represent it, okay? And also for the row or column matrix, we can use a lowercase letter or a lowercase bold letter to represent it. So it depends the notations you see. In some textbook, you can see the use of the bold capital letters. In some textbook, they use the lowercase bold letter, so it's still the same thing. Okay, so so for this now, so we can now say for an n by n, so n by n matrix. So like in this case, it's a 2 by 3 matrix, right? It's a 2 by 3 because it has 2 rows and it has what? 3 columns. So for n by n matrix, okay? So usually we use a bold letter, or basically a bold capital letter. So for example, you can, as in that example, you can use A. It's a bold capital letter. Now, but for a row or column matrix, so now this is a little bit different. For a row or column matrix, I've talked about this in a previous video. So a row or column matrix, we use a lowercase bold letter. For example, we can use A, and that is it. So basically, this is the matrix notation. Here, we just talk about how to represent it. The most important thing is that you need to take note of the double suffix notation. This is very important. So the first indicates the row, while the second indicates the what? The column, all right? So if, for instance, you have an A23, it indicates the second row and the third column, all right? And if there's no ambiguity, we can use for n by n matrix, we can use capital letter. And for a row or column matrix, we can use a lowercase bold letter. All right, so we're done with this. So let's get into the interesting part now. The next video, we're going to talk about how do we add and subtract matrices, okay? Addition and subtraction of matrices. So let's get cracking. Let's see how do we add. If we have 2 matrices together, 3 matrices together, how do we add and how do we subtract? So it's very important that you click the notification bell so that when I post the next video, you'll be the first person to know. So I'll see you soon. See you in the next video.